me okay? First, I must apologize to be the one to pull you out of that beautiful sunshine. So hopefully this will be interesting enough to have warranted it. So I wanted to just give you a quick little backdrop. Last time I was here was probably about 6 years ago for another reason, which is that I was looking at a technology called Spark that came out of the Berkeley AMP labs that all of you know about. And it was in its infancy. It had been in the lab for quite a while, really as a research project. And we and my co-founders at Clearstory spent quite a bit of time there with the founding inventors of Spark to determine whether it could be the next great thing for interactive querying of data. And we pulled it out of Spark, out of the AMP lab, and were one of the first commercial products to be built on Spark and helped form what is now Databricks. At that point, we weren't even thinking about machine learning or any such thing. We were literally just thinking about how do we query data faster at scale. About a year and a half after that was the next time I was here and actually talking about the possibilities around machine learning, much of which came out of what we had been looking at in Spark, and we were here with some of the folks from Google and Yahoo and all who had spent quite a bit of time on ML. And at that point, I would have said, we have a huge number of years ahead of us before we know whether ML is going to do anything great for us or not on data. And here we are now, 4 years since then, talking about AI. And it is amazing to me to think how fast this entire world of looking at data in a faster, interactive way, applying ML and applying AI has come. And honestly, a lot of what I'm going to talk about today are real applications of AI in business performance, because it is not about a vision anymore. It is not about the future. It is here and now. It is at work everywhere in a lot of organizations, and we're at the beginning of yet another great frontier in what's going to happen on artificial intelligence on data. So to that, on that note, interestingly enough, about 60% of companies will adopt some form of AI-powered technologies by end of 2018. And I'll talk about a few examples today that you may already be users of. You just don't realize that you're actually behind it all. There's a lot of AI happening. But I'll also go on and tell you more about how companies are using AI to actually drive higher value out of business performance, both for their own internal operations as well as their customer base and how they serve the consumer. So the number one driver for AI in large corporations today is really to deliver material impact to the business. It is and has been proven already that it can make a big difference to how companies service the customer, to their internal operations, to their supply chain, to their production, to their sell-through of their products. And that is why it is being adopted at a much faster rate than any of us had ever imagined, right? If it was still in its experimental stage, we wouldn't be seeing that, but it is definitely past that. And of course, at the center of all that, in order to leverage AI and actually want to invest a lot in it as a company, you have to first and foremost be willing to be 100% data-driven. And you have to make a commitment up and down the organization to look at everything in your company from a data perspective. Otherwise, basically, if you're not able to get to all your data and leverage all of it, you're not going to get the full benefit of what AI technologies can provide. So as you think about and look at how AI can add material value to the business and what it's really doing, the first thing is that when you apply a lot of or harness a lot of data underneath any of your AI technologies or AI-driven data analysis, the number one thing that it's doing, and this is really because ML is a component of AI, is learning about your data. So learning basically the patterns in your data, learning how to then reuse that to become smarter about what the systems and technologies then provide as output to stakeholders who are looking at this information. So learning models underneath are, of course, at the heart of it, and that's why we started this whole journey in AI with machine learning, right? And it's machine learning that has advanced enough to take it beyond just learning to the next thing, which is about prediction. So if you learn enough and apply the right models through ML, you're able to then take that information and cycle it through to predict better. So as a result, it's caused better prediction than we've had in the last generation of predictive models that we've become used to in some of the companies that have used it extensively. But it doesn't stop there. One of the biggest opportunities with AI is not just the learning from data and the prediction out of it, but really what some analysts call the surprise, right? And what I love about this is that if AI cannot surprise you with the kind of results and output that it delivers, then we might as well go back to humans doing it, right? So I'm going to talk about examples where it has worked so well to generate surprisingly good results. And that is really sort of the holy grail of where AI will take us. It's letting you see things in your data, in your business, do things for your consumer that you couldn't otherwise do just with learning models and just with prediction. It has to be able to generate an answer for you or information for you that otherwise would be impossible to do if you did it the traditional human-based way, right? I'm not going to say AI is ever going to be the brain smarter than any one human or collective group of humans, but it has got to surprise you in ways where we can take that information and with human intellect then go do something with it. So what are the kind of areas where AI has actually already proven to generate great results and frankly surprisingly great results? The first is around personal identity. So facial recognition and speech, and I'm sorry about the typo, it's supposed to say speech, not speed. Speech recognition and facial recognition are, of course, at the heart of how AI is being applied to be able to reveal personal identity, right? So you've seen it happen now with the iPhone 10 on facial recognition, but it goes further than that. Speech recognition is, as you know, one of the biggest areas everyone is researching because it's going to be able to identify humans beyond just facial. If you combine facial recognition and speech recognition, hopefully you've identified the person quite accurately. The second area where it's more fun, but might as well take something good and apply it to entertainment, is it's been used to demonstrate that using an AI model to play chess against a human has the AI model beating the human most of the time. So it's become an interesting way to apply AI to the gaming industry. And then composing music. Believe it or not, I actually was at Google the other day, and there was this amazing song playing in the lobby, and I turned around thinking that there was some unbelievable piano player there, and I literally turned around, and it said, AI-powered piano, right? And it was literally creating music, right? Beautiful, amazing music. And a new song was being generated all the time because it was all driven by intelligence around, taking classical music from the past and mixing it up and coming up with something new. And then the third area, of course, you all know all about this. I won't go much into it, but call it practical or call it cutting edge. I'm not sure which side of the fence you all come out on, but autonomous driving and language understanding are two other areas where either this is going to become a very practical thing with the application of AI, or it's going to be cutting edge and only a few will actually believe in it and adopt it, but still we have to wait and see what happens. But where AI is adding value to businesses, which is the point I made earlier, is I wanted to show you a few examples and then go on to how this all really happens and what happens under the hood. The first one is if you look at banking is actually using AI techniques extensively mostly through chatbots as the user interface mechanism, to be able to actually interface with a consumer and be able to tell you, how are you spending your money on a particular credit card? What are the breakdowns? How much have you spent on restaurants in a particular month or day or week? How much are you spending on rides? So on and so forth. So instead of going into your bank account and looking at all your transactions, you can simply say, tell me how much I spent on fast food versus, service-based restaurants versus car rides versus, miscellaneous things, and it is calculating all this for you and can answer quite an extensive set of questions. How many of you have actually tried something like this? So for those of you who have, and you keep watching this technology emerge, it's got a lot of promise in terms of banking, but not only that, in terms of detecting fraud and being able to identify patterns of fraud as well. So here's an example of fraud. If you actually asked, how did I spend the $649, and you see a couple restaurants pop up and you think, I never ate at those restaurants, well, that's your tip that someone else is getting into your credit cards, right? The second interesting place that AI has proven itself for business performance is, Airbnb's dynamic pricing algorithms. So if you look at this, it looks at seasonality, what kind of guests actually stayed at that particular place, how much were they willing to pay, where did they travel from, and based on all those factors, determine what the optimal price is for an Airbnb room. And then work into it seasonality factors. In this particular case, you see there's a Chicago Marathon going on. So you add that to the mix, and you add all the people who have stayed there before and where they've traveled from and what they've been willing to pay, and suddenly you're able to present the optimal price to charge for your room. And dynamic pricing algorithms have come a long way. It is absolutely very well done with what Airbnb has done, but that's not where it stops. There's a lot of retail and such that are going to borrow the success of this and apply it to their businesses. Another interesting one is, of course, in delivery. We're seeing a lot of this actually at Clearstory, where logistics and supply chain and AI applied to that is yielding the ability to optimize routes, reduce the number of trips a truck has to take to make deliveries, anticipate who is going to be ordering what, and be able to arrange the truck routes accordingly. Walmart actually is doing a lot in this area, but in addition to that, they're going to also do this not just for delivery, but in store, where through facial recognition, you'll be able to identify frustrated people in a checkout line. How many of you have been there? All of us have been there. And be able to see that you're frustrated when you see a long line and immediately open new checkout counters, whether they're like self-service checkout or otherwise, or manned, but to know that you're just utterly frustrated and new checkout counters have to be open to get people through. So how is this all happening? So at the heart of it is the ability to really start interpreting the meaning of data. And we at Clearstory and my last two companies, being data companies, did a lot of work on interpreting the semantic meaning of data values. In other words, everything you look at has a pattern, right? Or the machine looks at. And that pattern is an indicator of what the data actually means, right? So whether it is a SKU name or a person's name that's represented as a first name and a last name, or a first name, middle name, last name, or obvious ones like currencies and numbers and such, location information, proximity information, there are enough patterns available today where you can train your AI model on what the meaning of that data is and give it a confidence score, right? And by giving it a confidence score, you're able to then say, as long as I keep looking at this data and it keeps looking like that same pattern, then I have a high degree of confidence that it is what I think it is, and be able to make intelligent decisions and suggestions based off that. So I'll go into this in a little bit more detail, but one of the key things here is the continuous piece. You know, unlike a lot of analysis of data in the past where you looked at it in sort of a batch way, right, for AI to work, it has to be continuous. Every single data value refreshing or updating has to be continuously read. You can't pause, you can't stop it. It has to continuously be interpreted so that the AI model can get smarter and smarter on what it's seeing and deliver the results at the right time to the person or the stakeholder that needs it. How that all actually works is a couple of things have to get together, come together. So there's one piece of it, like I said, around interpretation of data. So what is in the data? What does every value mean? How do you actually understand and have a high confidence that the pattern matches to what you think it is, whether it's a SKU number or, like I said, an address or a person's name or a color? We have a lot of companies that say, look, you know, some people like to call red red and some people like it called dark red. Can you figure out how to classify all these things and come up with a pattern on how to recognize it? The second piece of it is data reconciliation. So when you see a lot of if you see a pattern, then how do you actually reconcile and confirm that it is what you think it is with a high degree of confidence? And if the AI model doesn't have enough data in it, then obviously that's hard to do, but that's why at the heart of all this is having a lot of data that's constantly feeding in. The transformation is where you're taking anomalies and you're taking those anomalies that you see in the pattern and reconciling them against the majority that you see that does match to a pattern, right? So if 2% of what you're looking at does not match to a pattern, while the rest of the 98% does, then how do you take that 2% and know how to transform it in an intelligent way so that it has a similarity to the pattern that you have recognized? But you have to do it in a way where you have seen enough of it, including the 2% anomaly, to know what it really is and how to match it, right? So it's this piece of it that a lot of new techniques are still being innovated on, which is, you know, taking the outliers and knowing how to then reconcile it with what does look like high quality pattern match data. And then finally, if you do these things right, you're able to actually discover with a high degree of confidence what the data means and how to treat the data and how to apply it towards answering a particular business question or whatever the application may be. So my main point here is that the real sort of brain behind AI-based systems is being able to first pattern match, see enough of that data, and then be able to learn from it and develop a high degree of confidence coming out of that on what that information really means. And across all the applications I just talked about, this is being successfully done, but we're still, you know, at early stages on this piece, which is how do you deal with the anomalies and transform them into something that matches or can be reconciled with the majority of what you see is correct. I wanted to show you a little bit about on what this really looks like. So here's a UI basically that shows you what I mean by interpreting the data and matching it. So as you can see here, there's all this information here on cities and the employee, whether they're self-employed or full-time or not employed, and true, false type of information, and so on and so forth. But the key is that you're constantly reading all this data coming from the source, and you're correlating it against every other dimension, because when you do pattern matching, you're not just looking at the data and interpreting what this means, but you're verifying what it means by correlating it with everything else to say that what we think this is what it is, right? Because you can't pattern match in isolation. You're going to pattern match by looking at a pattern in here and then correlating it with everything else you see to confirm that what you're seeing here is correct, right? So there are lots of algorithms that then kick in to determine and verify that each and every one of these dimensions here that is reading new data is correctly interpreted. Now, what happens next is once you actually you do this, at each point in time, you're scoring the interpretation of the data. And scoring, as you know, done many different ways in AI, is a key part of how the data is actually both interpreted and verified and validated in terms of what it is. So for instance, in here, if you interpret this data correctly and how it correlates with everything else, you're able to say that this source that I read that has called state FIPS information in it is actually similar data to what this source calls location. And actually, no human has actually come in to the mix here to interact with it. It is simply by reading all of this, interpreting meaning, looking at how they're correlated with each other to say, these two are actually similar data, right? So my main point here is that behind a lot of these AI algorithms is a very complex set of algorithms running. It's not one algorithm. It's one algorithm generating a pattern, another algorithm then correlating it with everything else, another algorithm then scoring it. And the scoring system is a lot of what AI systems depend on, the output of which is creating basically a continuously running feed of what the data really means, right? Now, the output of the scores is then what used as a signal to determine what it is that the user is really after and the type of answers you're sending them. So let me get to that next part of it. But what I wanted to just sort of affirm here is that this is the most complex part of what most AI-based technologies are doing, and frankly, most data-driven analytics technologies when it comes to AI. It's simply about how good is your system at reading every value, identifying a pattern in it, and how good are you at actually scoring the output of that to determine how to apply it to the application. Now, when it comes to taking all this information and presenting an insight, so whether it be the example I gave you with Airbnb or the banking example, how do you then take that information or the output and present it to the user in a way that the user is actually getting the kind of surprises that you want AI to deliver? So how that works is basically, and I'm going to show you a couple of interesting screens here. It's looking at the patterns, and the most important thing that comes out of this is this piece here, which I just want to focus on. When AI delivers an output based on interpreting the data, the next piece of it is how you display it to the user and how the user then interacts with it. Because you've now reached the point where it's the user interaction and the signal that's going to feed back in to tell the system that what the system has really discovered and interpreted is of high value or it's not of high value, right? If it's not of high value, then keep learning, keep understanding more of the pattern, keep returning a new set of answers. But if it is of high value, then the user is going to confirm that, which is basically a feedback signal to your AI model to keep doing more of the same, right? So this area here of how do you actually take AI output and marry it with the human interaction, and what type of user experience is the right one, for different types of products and technologies for that feedback mechanism is sort of the second big area of AI that is under heavy research. So for those of you actually who are looking to go deeply into this area and spend a career in it or continue to research it, there are really two opportunities. There's one that I just described, which is deepen the data, right? Create the models, create the pattern recognition, correlate pieces, continue to create the machinery around that. There's the other area of it, which is quite exciting, which is how do you actually present it, and how do you take the human interaction and signals back from the user to verify what is meaningful to the user or not. So I wanted to give you an example, or one example of what that looks like. It's actually an area that we're researching right now. So here's an example where the back end has gone in and discovered all this data. It's discovered everything that's going on with your labor, material, and parts costs per month for development and repairs. And it's constantly presenting all these insights to you. No human intervention. It's reading the data. It's understanding what is a labor attribute, what is a material, what is a part, what are the costs, so on and so forth. And this is like automatically generated, right? No human doing any wiring or prepping of data or models or data modeling or any such thing. Now that you've presented this, you could stop right here. But that's not where we want to stop if AI is going to really deliver the surprisingly wow moment for the user. The real opportunity here is to then turn the output of this into conversation and interact with the human in a conversational way that's very natural. And so here's an example where it says, look, we noticed that the costs here are higher than expected for labor, pain, and parts in the weeks of March 28th, April 4th, and April 18th. And you say, really, I don't care about parts, I just care about labor and pain, and you just toggle those. Maybe you care about all three, you keep them all enabled. Would you like to explore more? If the user says, no, I don't, right? Basically, what you've told the system is this information is just not of interest. So go find other patterns and come back with something else that they may find of interest. So that is what I mean by the feedback cycle. If the user says, yes, this is of interest, then you keep digging deeper into the data, keep discovering more of what they're interested in, and continue to show them more information. So literally what you're doing is taking AI-based discoveries, combining them with human interactions to learn what is of relevance to the audience that you're, or user that you're presenting to, and giving them more of what they acknowledge that they want, and giving them less of what they don't find interesting, but then finding other patterns for them and continuing to present that, right? This is exactly what was happening in the banking application too. If you keep telling me I'm spending this much on restaurants and I'm just not interested in knowing more, then don't keep telling me that, right? Tell me how much I'm spending on my Uber, or tell me what I'm spending on my other transactions. So this feedback mechanism is a great area of research. It's actually the area I find really exciting, because I think that the opportunities for user experiences that become incredibly personal to each user and incredibly compelling to get that feedback is a massive area of opportunity. And it is, you can combine all kinds of research going on facial recognition. I mean, imagine if you built that into here and you showed me this and I squirm, and that's another signal back saying, why are you telling me this? I'm not interested, right? So I'm showing you one example here of conversational UI and feedback mechanisms. But if you look at this area of research, there's a huge amount of opportunity here on how to design user experiences against the output of AI that are highly personalized, and a very, and through personalization, gives you the ability to deliver a very high degree of signal back from the AI model to what the human or individual cares about back into the system. Now think about if you had an app where a lot of people were doing it, then you crowdsource all of that, right? And you take the crowdsourced output and you could present it here and say, are you sure you don't care about what happened with your labor and pain costs? Because 30 other people who looked at this do care about it, right? 30 other people looked at it, care about it, and you're going to then say, all right, there's some reason everyone else cares about it, maybe I'll take a look, right? And that starts your journey again. Or you could still say, no, I'm not interested. So, what we're doing here is taking all kinds of new user experience techniques to be able to understand how to get the human interaction married with the AI output to be able to deliver a better signal to the AI model. That's like a talk in itself for another day, because I know we're limited on time. Originally, I was going to actually spend a lot of time talking about this because there's such cool user interfaces and user experiences coming up around this area. A lot of them still experimental, but I think we're going to start seeing some really innovative things come out of this. So in the interest of time here, I have a couple minutes left. I just want to summarize that if you're working on the data side of AI, then, like I said, it's about interpreting data, identifying all data values, transforming complex data without any manual effort, and continuously discovering patterns. Scoring all of it for relevancy so that each time you read new information, you are constantly keeping scores of what is most relevant and what's been discovered. And this part of it, meaning discovery of surprises, is really taking the AI models and what is generated from it, and how that is then presented to the user and the human interaction signal, right? So how what the user finds of interest and how they interact back with the system, which then feeds right back into here. Sounds really simple, but at the end of the day, this is a great area of research, and this continues to be a great area of innovation. So to sum it all up, I told you that 6 years ago I stood here and we were still talking about better ways to just query data at scale, and that's when we spent a lot of time at Spark and other such technologies. Then came massive amounts of time here. I spent massive amount of time here looking at ML models that the labs were creating, including AmpLab. And now we're on to AI. And AI, believe it or not, is going to hit a $100 billion industry by 2025. The combination of what I talked about in the back end, or people actually designing systems that are smart about data, and people designing systems that are very smart user experiences, is literally a massive industry. It's being applied to drones, robotics, building development, data analysis, all kinds of things. So definitely an exciting area, just astounding growth. And by 2020, which is actually around the corner, about 85% of customers will actually manage their relationship with a company or enterprise without ever interacting with a human, right? Most of you already do it, whether it's airlines or whatever it may be, but pretty much 85% of anything you do, whether it's in a product you buy or a service you use or whatever you may do, will not have a human behind it. Scary in some ways, but that's where we're going. So with that, I just wanted to say that if you're interested in this area, there's a ton of opportunity. It's a really exciting space. And at the end of the day, whatever you do on the back end of data or on the way that information out of an AI model is presented, your goal is to surprise and wow the person at the other end who is the recipient of it. Okay? All right.
Sharmila, thank you very much. We've got time for 1 or 2 questions. I've got a couple of hands straight up, so let's go to the gentleman nearest to you first, and then we'll come forward.
So the thing with surprises, how do you know, what do you define as a surprise?
Yeah, great question.
How do you measure surprise?
Yeah, so surprise is, as I mentioned, that the interaction with the human, where I showed you an example where we said, this is what we found, do you want to know more? The more they keep saying, yes, 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 show me more, it means that you're giving them information that is of great interest to them, right? And instead of even just saying, yes, this is interesting, you could change that experience where you can delineate between what they're not interested in all, what is a matter-of-fact yes, and what is a wow moment, right? You could ask, like, are you surprised to find this result, right? This is what I mean with all the UI techniques coming out around this. And that's where the UI comes in. Like, you have to learn from the human interaction based on the output of the AI model, whether they actually find it sort of a ho-hum kind of answer or a wow moment, right? And so that's the option in the user experience side of this, right?
Just to the front there, thank you.
So a very similar question, but let me ask it differently. How did your system calculate the expected value in the
Yeah, so by actually continuing to read the data from the source, right? So it's mashing up data on the labor parts and such, as well as all the sales numbers of each of those. And what it's doing is actually looking at the correlated data values, right? So reading every value, correlating every single value with each other. So every attribute with each other and every value that's refreshing all the time to come up and say, we found 3 days that have had unusual sales, right? Because what you're doing, the nice thing about AI is that the whole history, whether the user ever wanted to know it or not, you're keeping an audit trail of everything that happened, and you're looking at current point in time, and you're predicting, right? You take those three together, and you can actually give them information right down to the day or the hour that they would otherwise find very hard to glean out of a chart, right? So what is presented on the face of the application is just a tiny piece of what the system actually knows, right? How do you actually get the rest of it to be revealed to the user? It's through this yes or no journey. Make sense?
Okay. Okay, we've got time for one more question. Gentleman with his hand up there.
Is there a way to tell between situations where there's something that the user is not interested in, but like really should be, versus what's actually a bad pattern, right? That some people are just stubborn.
So to discover what is a really bad pattern is two ways. I mentioned the crowdsourcing. You have to, it's a matter of like the number of people, right? What's a bad pattern when enough people are saying they're not interested in it, right? Means that you're generating something out of the pattern that is of little value to not just an individual, but because an individual is not, a sample size of one doesn't matter, right? That you have enough of a sample size of people viewing it to acknowledge whether it's of interest or not. So that means that you're generating something that they're not interested in versus a crowdsourced mode where you're getting a lot of repeated people to say that this is of interest, right? You know, funny enough, I was at a board meeting this morning and an example was brought up of something Amazon is doing. Well, I think they thought this model was going to be, nobody here works for Amazon, right? They thought this model was going to be really smart, but it's actually backfiring. So when you buy something on Amazon, it's now sending you emails saying, you just bought this, do you want to buy more of this? Well, ironically, it's not just doing it for, you know, your detergent that you just bought, it's doing it for the TV as well. Well, what are the chances that I bought a TV for $5,000 yesterday and I want to buy one again today? Right, so that's an example of a model gone wrong, right? Nobody's opening those. In fact, they're like deleting those emails. That's what Amazon is finding. That's how they discovered that they have this terrible model that is unanimously applied to everything. Well, everyone's like deleting the email or not opening it because the headline actually said, want to buy a new TV? Well, why? I just spent $5,000 yesterday. You might want to tell me a week from now, hey, do you want to buy more Diet Coke? You bought a 6-pack last week. That's fair, right? And I open it and I say, yes, please, you know, go ahead and order, right? I mean, that's what you do in that model. But that's a great example of a user experience and the human signal back.
Okay, Sharmila, thanks so much.